Hey, welcome back. So we are on to section 3. Hopefully this first little subsection will be kind of a quick hit video and then on to more content. This section's broken out into a few more pieces than our previous ones have been. I think it's 8 altogether. So we're heading into new categories of functions. So we just hit linear functions, and this kind of brings up the mathematically logical question like, well, we had these linear functions and they only had our regular old variable. We couldn't do anything to that variable, no square roots, no extra powers, stuff like that. So what would happen if we chose kind of the minimally next interesting thing to do with it, where instead of just having, say, a t or an x for our variable, maybe we could have an x squared in there somewhere. And so what that takes us away from is linear functions and into quadratic functions, this sort of a new family of functions to think about. So this first subsection has, we're talking about quadratic functions, and the learning objective is to identify a function as quadratic based on some formula. Okay, so just one example to kind of get us in the ballpark here, but here's our definition. So quadratic function is something that can look like this. So I've been a little cagey with my phrasing here. Can be written in the form, so it may not look perfectly like this to begin with, but we can get there. So a, b, and c are constants, and we just don't want a to be 0. That's pretty much the only thing we're concerned about here. Okay, so we are looking at a new category of functions, and if you sort of imagine a linear function is lurking in here somewhere, and maybe let's tie this into the why not 0? Why can't a be 0? I don't know if this is like my kids, but anytime you tell them you can't do something, the immediate question is, well, why can't I do that? And then they become very interested in that thing you can't do. So let's ask why not. So if a were 0, then our function looks like f of t equals 0 times t squared, and then plus some other stuff, bt plus c. And I guess the upshot is then if what we have is a 0 at the front of this, basically this term has been canceled and we don't really have anything interesting going on with that. Boom. And so what's left over? We have bt plus c. Well, it might not look like it right away because the letters are different, but that is a familiar function. I'll wait for you to scream it at your device. What type of function is this that's left over here? Okay, hopefully you're screaming linear function at the moment. So this is a constant times variable plus some other constant. That's exactly the type of function we were dealing with in section 2. So that would not be a new function. If we have a 0 for that leading term, we don't get quadratic anymore. It's this t squared thing that kind of gives it the pizzazz to make it a new type of function. Okay, so b and c don't have that same condition on it. We can have anything happen with those ones. It's only a that has this restriction. Okay, so some venturing into the territory of quadratic functions. Let's take a look at f of t first. So here's f of t is 3 minus t plus 4t squared. And the question is just whether or not it's quadratic. I should be kind of encouraged by this 4t squared thing. So I guess one thing we might try to do, and in the spirit of this can be written in this form, let's try to put it in that form. Let's try to look at it as something times t squared plus something times t plus maybe something else. So here the 4t squared would come first. We'd have minus t next, and then a plus 3 at the end. And so now what we're looking at is whether or not we could basically figure out these constants, essentially. So if we've got it in the right form, then we know that, let's see, so a is the constant out in front of the t squared. This one takes a second maybe, but this is really just minus 1 times t. So that b constant is -1. It is important that that negative comes along with it, because our formula looks like plus something. So in order to get a minus, b would have to be a negative number. And then our constant c at the very end. So yes. Looks quadratic. Delightful. What about g of t? This looks a little odd, but maybe we can try it, right? So g of t is, so I don't see anything with t squared here. If we really were trying to shoehorn this in, just kind of force it into there, we could try 0t squared, and then we'd have minus t and plus 3. And this looks very much like the function we were just working with, but with a really, really important difference. There's no 4 in front of this t squared. So here, now what we're looking at is exactly the thing we're being told we can't do, because then a would be 0. So you could still kind of go through and say, oh, what do these constants look like? But the conclusion is no, because we were specifically told that a can't be 0, and that's because this is really a linear function. A mathematician might call this a degenerate quadratic, because it sort of thinks it's a quadratic, but it kind of disintegrates down into a linear function when you really look at it. But for our purposes, no, not a quadratic function, because we're told a can't be 0. One more of these to think about. So h of t, so this is, all right, pi times t squared. And if we were going to play the same game with this one, we would try to write it, so there's only one term, I guess we'll put that first, there's t squared. And then if we really were forced, we could say this is 0t and plus 0. That technically is the same as that formula up top. So remember, this is where the fact that a gets treated differently from this other constants might actually save us. So here a is pi, which maybe you'll forgive me for, maybe not. And then b would be 0, because there's no linear coefficient here, or no linear term at all. And then 0 would be our constant, because there was no constant showing in this original function either. But that's actually fine. So a is not 0, b and c are, but all right, that's just how it goes. So actually, we're totally fine with this being quadratic here. Let me see if I can actually get words written. Yes. Okay, so that's it for subsection 1. We're going to come back with some more stuff with quadratics here next.